Hello students, in this lecture we'll discuss how to convert the rectangular coordinate system into curvilinear coordinate system, and we'll discuss the uh, problems in curvilinear coordinate system and orthogonal coordinates in curvilinear coordinate system, both in tangential form and normal form. Now, first, let us define transformation coordinates. How we transfer from rectangular to rectangular coordinate system to curvilinear coordinate system. What are curvilinear coordinate system? So let the rectangular Cartesian coordinate of any point P are x, y, z in space be expressed in terms of three independent single valued and continuously differentiable scalar point functions u1, u2, u3. Let the rectangular Cartesian coordinates x, y, z of any point P in the space be expressed in terms of three independent, single-valued, and continuously differentiable scalar point functions. Function u1, u2, u3 are x is function of psi1 of u1, u2, u3, y is a function of psi2 of u2, u3, u1, u2, u3, and z psi j of u1, u3. Suppose that the Jacobian of xyz with respect to u1, u2, 3 does not vanish. Means if Wronskian does not vanish of this means they are linearly independent. So we can transform from Cartesian to this curvilinear to Cartesian if the Jacobian of x or z is to u1, u2, u3 is not equal to 0 means they are linearly, these functions are linearly dependent, or vice versa, or partially if u1, u2 is to x, y, z is not equal to 0, then you can write u1, u2, in terms of x, y, z. Then u1, u2, 3 can be expressed if they are independent. Then u1, u2, 3 can be expressed in terms of x, y, z also given by u1 is equal to phi 1 of x, y, z, u2 is equal to phi 2 of x, y, z, and u3 is equal to phi 3 x, y, z. Due to the condition imposed on these functions, with each point P with coordinates, Cartesian coordinates x, y, z in space, due to the condition imposed because they are independent, there exists unique triad of numbers u1, u2, u3 for each point in space. There exists a unique triad of numbers u1, u2, u3, and each such triad to each such triad there is a definite branch in space, right? Uh, in the Cartesian, is there any point in space? So there exists a unique triad of number this, and each such triad in space has a definite point in space. So for these points, any point can be if in the Cartesian coordinate, so that can be converted into unique triad of u1, u2, 3, and these triad will be unique for each point in space. Then the set u1, u2, 3 are called the curvilinear coordinates of point P. The set of the equation first and second, set of the equation first is this, and second is this. First, define the transformation of coordinates. Here we are given x in terms of u1, u2, 3 curvilinear coordinates. Now we can write the curvilinear coordinates in terms of the actual in the rectangle. This is called the equals first second we define the transversal coordinates, right? Orthogonal curvilinear coordinates. Now surfaces. The surfaces you converted this equal to xz u1 of xz equal to c1. Z is equal to c1. U2 of xz equal to c2. U3 of xz equal to c3. Where c1, c2, c are constants. Called coordinate surfaces. These are what are they? These are coordinate surfaces, and each pair of these surfaces intersect in curve are called coordinate curves or lines. Right? Two curves, they are surfaces in space. Their function of z means we are talking in Cartesian coordinate. So if you take two surfaces at a time, they will represent a curve. U1, U2, U2, U3, U3, U1. They represent, if you take two coordinate surfaces at a time, they will represent, they will give us three curves or three lines. Thus, U1 curve is given for simplicity. U1 curve is given by U2 of xz equal to C2 and U3 of xz equal to C2. And U2 curve is given. U2 is not U1. U1 3, U1. 1 and 3, U2 curve. 1 and 2, the coordinate axes are determined by the tangents. By the tangents PQ1, PQ2, PQ3 to the coordinate curve at the point P. If at every point P with rectangular coordinate x, y, z, the coordinate axes are mutually propagated. When we say PQ1, PQ2, PQ3 as a coordinate axis, what the point is? You see this coordinate point is point P. If they are mutually perpendicular, then U1, U2, U3 are called orthogonal curvilinear coordinates of point P. The curvilinear coordinate system is orthogonal if the three tangent planes or tangent planes will be to the curve and normal to the three surfaces through every point are perpendicular. So every point, if you take any point in space, the curvilinear coordinate system is, will say they are perpendicular or orthogonal if the three tangent planes to the curve or normal to the three surfaces are at each through every point are perpendicular in pairs. Also in an orthogonal curvilinear system, the lines of intersection of tangent planes of surfaces, any two surfaces is normal to the third surface. So then we will say that curvilinear curves are orthogonal. So let us see diagram. Now this surface is this is from P. This surface is this is U3 equals to this surface, and this surface is this, and this is U2 is equal to surface, and this is equal to this surface is U1 equals to this surface. Now um, uh, U2 is equal to C2 surface and U3 equal to C3 surface. U2, U3 equal to C3 surface intersect along with this curve. It will be U1 curve. And U2 is equal to C2 surface and U1 is equal to C1 surface intersect along the curve. This is U2, U3 curve. And similarly, U1 is equal to C1 surface and U3 and U3 is equal to C3 surface intersect along the curve. Yes, U2 curve. Right? Now tangent along this is equal to PQ1, PQ2, and PQ3. They are tangent along the curve. This is U1 curve, This is along U2 curve, and this is along U3 curve. And E1 is a normal to the surface. E1 is normal to the uh, surface, and E2 semi-surface is the normal to the E2 normal to the semi-surface. E1 is normal to the first surface. E3 normal to the third surface. E1, E1, E3, the normals. It's a diagram which I have discussed. Now we'll discuss if the E1 if the E1 interpreter, E2 interpreter, this E1 is interpreted along the uh, tangent to the curve given surface, and E2 is interpreted along the tangent to the surface U2 curve to the curve U2 curve, and E2 E2 surface along the E3 is along the curve E3 curve. These are the normal surfaces. These are tangent orthogonal tangential tangents, and they are normal, right? So condition for orthogonality. What the condition for orthogonality? If the surfaces are orthogonal, what is the condition of that? In curvilinear coordinate system, one function x z, two function of x z, these functions say phi 1, phi 2, phi 3. Solve the above equations for x z in terms of u2. One discussing the first transfer x z. We can solve because they are independent. They can be solved in terms of x. So from the equation, we will write x in terms of u1 u3, y equals u2 3, and z equals u2 3. That is psi 1, psi 2, psi 3. Let R vector be the position vector of any point P. This point is already different, etc. Therefore, R is equal to x r double y j plus z k. Now substitute the value. Okay, in terms of u1, u2, u3. So now this is equal to R is equal to the function of z vector. Coordinate curve, coordinate curve u1 curve, coordinate u1 curve passes through two surfaces, u2 is equal to c2 and u3 is equal to c3. Therefore, its equation will be in this. If we replace u2 by c2 and u3 by c3, so this r vector is equal to f vector of u1 c2 c3 will give the equation of the coordinate u1 coordinate curve. Similarly, if you want to write the equation of the u2 coordinate curve, what will be that? That will be u2 will be you replace u1 by c1 and u2 and the and similarly u3 curve will be r is equal to f of c1 c2 and tangent to the coordinate curve u1 curve coordinate u1 curve is parallel to the vector positive r is to tangent. What is tangent? Tangent will be parallel to this. If we take position point, differentiate this to u1 in the current coordinates, we'll get the it will be tangent parallel to this. The direction is to the normal the tangent will be given by this one. Similarly, the tangent to the curve of the two other two curves will be given by tangent parallel to other two curves will be given by positive r u2 and positive r. Now, the three tangents are for the orthogonal curvilinear coordinate system. If this coordinate system is orthogonal, now we convert it into this Cartesian to curve. This we have taken in the this we have taken in the curvilinear coordinate. This is we have taken in the Cartesian coordinate, and this become v1, v1, v2, v2 become the curvilinear coordinate. So, the orthogonal for the orthogonal curvilinear coordinate system, the above equation taken two at a time are true. If the curvilinear coordinate is orthogonal, then if you take first two tangents, they are perpendicular, they dot product is 0. The other two was two there is a parallelization test for two tension, and second, third and first, they dot product. Zero means the coordinate system, current coordinate system, and the solution is the option. So if you are to optimize, this we have discussed this lecture. Now we will discuss